Hi, Assalamualaikum. First of all, I will introduce ourselves first. My name is Nisa Farzada binti Abdul Rashid. My team members Aina Aisyah binti Azhar, Wan Ines Patricia binti Har, and Nur Anissa Sofia binti Jamsari. So, we will talk about our topic, analysis of function, first and second. So yeah, let's go. I will start with the introduction. So here we have two functions, which are polynomial and rational function. So they actually have the same step, but the difference is the starter. For polynomial, have to find the critical point first, but the rational we have to find the x and y intercept and vertical and also horizontal asymptotes. After that, the other step is same, which is find the increasing, decreasing, the concavity, the extreme points, and the last is sketch the graph. So that's it.
My name is Wan Ines Patricia. So the first question is rational function, which is negative x over 1 minus x plus 4. So the first solution we will find is the y-intercept and x-intercept. Number 2 is we will find the vertical and horizontal asymptotes. Number 3, we will determine the intervals where a function is increasing or decreasing. Number 4, we will determine the intervals where function is concave up or concave down. Number 5, we will find the inflection point. Number 6, we will using all the information to sketch the graph of function using Desmos.
Hello everyone, my name is Nur Anissa Sofia binti Jamsari. My student ID is 2022451924. To solve this question, we have to find y-intercept and x-intercept. X-intercept when y equal to 0. First, we calculate 5x plus 4 divided with 1 minus x. Do the calculation until we get x equal 4 over 5. For y-intercept is when x equals 0. Y-intercept is when we change equation fx with 0 and the answer we get 0 and 4. Next step, we find the vertical and horizontal asymptotes. To find vertical asymptotes, we let hx equal to 0. We choose in the equation of 1 minus x and then equal 1. For horizontal asymptotes, we use limits 5 over x and we got 5. We need to find either this graph are interval increasing or decreasing. First, find f prime s. After that, we use quotient rule and get the answer for f prime s. Replace fs with 0 and we got s is 1. Then we do the interval table and we got the interval is decreasing. After that, find either interval is concave up or down. Same calculation with previous slide, but in this, we have to find f prime prime x. Then do the table and list which concave down or concave up. From the calculation and table, concave down is negative infinity to 1. Meanwhile, concave up is 1 to positive infinity. For this question, no inflection point has found. Overall, using all the information we calculate, here are the graphs using decimals.
So the second question is polynomial function, which is negative x power of 3 plus 9x power of 2 minus 24x plus 2. So the first solution we will find is the y-intercept and x-intercept. Number 2, we will find the derivative of function. Number 3, we will find the critical values and critical points. Number 4, we will find the interval where the graph of function is increasing or decreasing. Number 5, we will state the maximum point and minimum point. Number 6, we will find the second derivative of the function. Number 7, we will state the inflection value and find the inflection points. Number 8, we will determine the intervals where function is concave up or concave down. Number 9, we will using all the information to sketch the graph of function.
First, we need to find the x-intercept and y-intercept. For x-intercept is when y equal to 0. So, for the function fx equal to 0, we calculate until we get 0.08608 and 0. For y-intercept is when x equal to 0. substitute 0 into s. And we get negative 0 cube plus 9, open bracket 0, close bracket, square, minus 24, open bracket 0, close bracket, plus 2. We calculate until we get 0 and 2. Secondly, find the first derivative of fs. To find the first derivative of fs, we need to differentiate the function that given, which is negative x cubed plus 9x squared minus 24x plus 2. So we get f prime x equal to negative 3x squared plus 18x minus 24. Thirdly, find the critical values and critical points. To find the critical values, we need to let f prime x equal to 0, which is negative 3x squared plus 18x minus 24 equal to 0. By that, we get critical point, which is negative infinity 2 and 4, positive infinity. Fourth, find the interval where the graph of fx is increasing and decreasing. We can find the interval from the first derivative of fx. For the interval negative infinity to 2, we choose test value 1. For interval 2 to 4, we choose test value 3. And for interval 4 to positive infinity, we choose test value 5. The sign of fx is negative 3x squared plus 18x minus 24. So, fx is increasing at interval 2 to 4 and fx is decreasing at interval negative infinity to 2 and positive 4 to positive infinity. Fifth, state the maximum point and minimum point. When x equal to 2, sub x at fx into 2, we get negative 2 cubed plus 9 multiple to 2 square minus 24 multiple to 2 plus 2, and we get negative 18. When x equal to 4, sub x at fx into 4, and we get negative 4 cubed plus 9 multiple to 4 square minus 24 multiple to 4 plus 2, and we get negative 14. If minimum point is 2, negative 18, and maximum point is 4, negative 14. Sixth, find the second derivative of fx. To find the second derivative of fx, we need to differentiate the first derivative of fx, which is negative 3x squared plus 18x minus 24. We differentiate it and we get f prime prime x equal to negative 6x plus 18. Next, find the inflation value and state the inflation point. From the second derivative of fx, we can find the inflation value by let f prime prime x equal to 0, which is negative 6x plus 18 equal to 0. Calculate the equation until we get x equal to 3. So, the inflation point is negative infinity to 3 and 3 to positive infinity. After that, find the interval where the graph of fx is concave up and concave down. We can get the interval from the second derivative of fx. For the interval negative infinity to 3, we choose test value 2. And for the interval 3 to positive infinity, we choose test value 4. The sign is f prime prime x, which is negative 6x plus 18. Then, fx is concave up at interval negative infinity to 3 and fx is concave down at interval 3 to positive infinity. Lastly, using all the information, you can sketch the graph of function fs. Lastly, I will conclude that we can determine the critical point of the function fs as well as the x and y intercept by analyzing the function. Next, by using the first derivative from the given function fs, we can find the increasing and decreasing interval. After that, concave up and concave down can be found by using the second derivative from the given function of fs. The value of that we obtain from the second derivative will be determined as the inflection point. By using all the values that obtained from the first and second derivative, we can sketch the graph of function fs.